So, Thomas, stage is yours.
Thank you very much. Yeah, ladies and gentlemen, experience in additive manufacturing. I take pride in presenting you our experience in long and painful introduction of additive manufacturing to aerospace industry. You see entitled series production, so you can imagine that we managed our way so far. But as I mentioned, it is a 10 years long story. You heard this morning from Mark Vettel something like some regulations and a few parts in the aircraft as well. Okay, so honestly, aerospace industry is of course prevailed by quality, safety and assurance, safety, which is prevailing anything. So being innovative, just entering with a new process or a new product into an aircraft, forget about that, because everything that counts is safety. So usually you bring new products or processes into a new product. So the product life cycle in aerospace and civil aircraft is about 40 years. So you have every 40 years the chance to be really innovative. That's a long way. So in between you have some, of course, modifications on the aircraft where you might bring in slighter modifications if they pay off. So you need a good business case, which is for a new technology not very easy to achieve that. I'll show you a little bit why. Slide picture for the background. What is Premium AEROTEC? 100% daughter company of Airbus and becoming Airbus within the next 2 years. I don't want to emphasize about the Airbus structure, which changes this year in Germany too much, just to see where I'm working. It's basically Premium AEROTEC or Airbus. Yeah, why do we do additive manufacturing? Why decided we in 2013 to go for that? Sustainability was not the major case in 2013, of course, but if you imagine the standard material processes like casting or forging and so on, of course they are characterized by high energy consumption, and additive industry provides let's say an opportunity to much improve that energy balance, to get rid of the energy consumption, to get a smooth digital workshop, at least in the first case, if you don't look too much into the follow-up processes, but anyhow. So you get safety value streams by applying additive manufacturing. So that's where we go. And you can see from the pictures, we are working with GE additive or concept laser machines from the start to now, because yeah, it's a long story of continuous improvement on the machines you have to perform in order to get aerospace parts done at the end. So as I said, 10 years. And again, why? Of course, I think we heard that very often up to now. Aerospace business should be one of the best cases for additive manufacturing, since the number of pieces is always in rather low, so small series production is prevailing. We afford, for safety reasons and quality reasons, it's allowed to be a bit more expensive compared to car industry or something like that. And from famous former processes, you see some examples here on this page. We had processes which last long, which are rather complicated, especially if we look on such connectors made from titanium parts, several parts milled or casted and welded together. So a lot of opportunities for them to improve that. The problem is, in fact, in aerospace regulations. So to bring new material into the aircraft, you can count about 10 years, something like that, to get the material maturity proven by the authorities, then to bring in first parts. We had a long roadmap agreed with the authorities, the governmental authorities in the world, to make that happen. And in fact, you undergo audits. I would say currently we have almost every 2 months an audit, so which is not very productive, but it's taken care that we are maintaining all the processes we qualified, all the material qualities, and so on, in order to be process qualified for Airbus parts and to bring in parts into the aircraft. So it's a long-lasting and, in brackets, expensive experience. You have to go, and of course that's nothing where you can use small and medium-sized companies, because it lasts very long and it costs a lot of money. So far where we are, as I said, we started in 2013. In 2019 we managed to achieve the process qualification. That means that we can bring titanium parts into AM design into the aircraft, Airbus aircraft. Of course, a lot of steps were necessary to do so. So we optimized support structures. We have to qualify the material. We set up with partners, EOS and Daimler, an automated cell to produce near-net shaped parts fully automatically in 24/7 hours. So a lot of steps were taken to improve the whole AM system. I would say to industrialize it, because in 2013, it was piece part manufacturing for unique parts, something like that, far away from any industrialization necessities. So where we are, in fact, you can see from the curve also we had a COVID downstepping in 2020 and 21. Nevertheless, you can see on the upper left-hand side the first parts that we brought into the aircraft. Very simple parts, absolutely negative business case, just because the authorities required us to do very simple parts with best quality material, parts which are more or less unloaded, and you can easily imagine that the business case is then far away. But it was the prerequisite to bring further parts onto the aircraft. So first, very simple low-loaded parts. When they are flying, then we can go to dynamically loaded parts. After that, we are allowed to do some topology optimization. And now, a couple of years later, we are in the stage that we can bring every part we want, dynamically loaded, into the aircraft. Not safety relevant parts up to now, but at least dynamically loaded parts can be designed, topology optimized, and are allowed to fly if they are produced by us. You can see the ramp up on the right-hand side, which is still going on. And there I can also say from the experience, we started with brackets. They look very famous, topology optimized, but in fact, there is no large business case on brackets, and your build chamber is almost limited in its space. So in aircraft, the geometrical conditions require more larger parts, so then we are more talking about maybe the wire arc processes instead of powder bed. Here in this case, we are focusing now on hydraulic parts, so something like manifold connectors, and these are the parts which allow us now to ramp up our business. Let's see it very steep. You see that we are now at about 2.5 tons this year of titanium. We are producing titanium parts, and it's fastly growing. How do we manage it cost-wise? Of course, we invest in new machines, and together with GE, we optimize the machines, getting better and better. We develop new parameters, increase the production outcome. So at the end, now we decrease the prices by more than 50%. Now we have positive business cases, and next steps are already, going on and passing. So for the aircraft and sustainability, I would say even small parts could bring several tons of CO2 reduction if they are acting on an aircraft. So that's a sustainable business case as well. So we go for that. And finally, from the trends, I don't want to go into too much details through the presentation, but of course, from simple parts, we are now able to do complex parts, also parts which are dynamically loaded. And technology is developing. AM is not at the end, but it's a key technology for the future and for our future aircrafts. So by that, you get the presentation later on. 10 minutes are not too much. Now it's finished. Thank you.